Let's consider the following problem. If the price charged for a candy bar is P of X cents, then X thousand candy bars will be sold in certain city where P of X is given by this expression. We are to find an expression for the total revenue from the sale of X $1,000 or X thousand candy bars, and find the value of X that leads to a maximum revenue. Then find the maximum revenue. First, let us find the revenue function. So the revenue function is obtained by multiplying X thousand candy bars. So X thousand times P of X. So this is just equal to X times 1,000 times, so X thousand times your P of X, which is 163 minus X over 10. And then simplify this, you have 163,000 X minus X squared thousand all over 10. So that's 100x squared. So this is 163,000x minus 100x squared. This is your revenue function. Now the revenue here will be in cents. So just take note that it will give you cents because P of X is in cents. So next, find the X value that leads to a maximum revenue. In other words, we are to find the derivative of R of X, the derivative of the revenue function, so that we can find the critical number. So the derivative of 163,000 is 163,000x is 163,000 minus derivative here is 2 times 100, so 200x. Then let's equate this to 0 to solve for the critical number. So to solve this, we are going to move this to the other side of the equation. That is the same as adding both sides of the equation by 200x. So doing that, you get 163,000 equal to 200x. And to solve for x, you just divide both sides by 200. So you have 1,600. So let's plug this into your calculator. So we have 1,630 divided by 2. And that is equal to 815. So X is 815. Then, lastly, let's find the maximum revenue. So we are going to evaluate our revenue function at 815. So R of 815 is equal to 163,000 times 815 minus 100 times 815 squared. So take note, this one is in cents. Now let's plug this into our calculator. Now upon plugging this into our calculator, I got 66,066,422,500. And this is in cents. Now we are to write the revenue in dollars. So writing this in dollars means you divide this by 100. So divide this by 100 to convert it to dollars. So therefore, the answer is 66422. Just cancel the 2 zeros. 4225. So that is 664,225. Now let's consider the next problem. The following demand function, this is the demand function Q, is equal to 36,300 minus 2p squared. We are to find the elasticity of demand, the elasticity of demand function E, and then we want to find the variables of Q, if there's any, at which the total revenue is maximized. So let's begin by computing the elasticity of demand function. We have a formula for E, and this is just equal to the negative of our variable here. The demand function is in terms of P, so that will be negative of P times the derivative of the demand function, the derivative of the demand function Q with respect to Q with respect to P, Q with respect to P divided by the demand function Q. So following this formula, we're just going to get the derivative of the demand function with respect to P. So from here, d dq dp is equal to the derivative of this is 0. So that is just negative 4p. Negative 4p. So you have negative p times negative 4p divided by your Q is 36,300 minus 2p squared. So you simplify that, negative times negative is positive. So this is 4p squared all over 36,300 minus 2p squared. So this is the elasticity of demand function. Again, just by following the formula here. So next, we are to determine the value of Q that maximize the revenue. So when you say, when does the revenue is maximum? The revenue is maximum when elasticity is equal to 1. So this is true when E is equal to 1. So in other words, this equation here, 4p squared all over 36,300 minus 2p squared, that should be equal to 1. Now, when will this be equal to 1? This is equal to 1 when both numerator and denominator are equal. So you have 4p squared is equal to 36,300 minus 2p squared. Then you solve for the equation here. We can move this to that side. That gives you, so that is the same as adding both sides by 2p squared. So you add here 2p squared. So that gives you 6p squared is equal to 36,300. Then you divide both sides by 6. Now this, when divided by 6, is equal to 6,050. So you have p squared is equal to 6,050. Then p is equal to the square root of 6,050. So you get positive, negative. But we are looking for Q. And Q here is demand function. So that means, and P is the number. So also P is the number of quantity, the number of elements. So we know that P needs to be greater than or equal to 0. So P needs to be positive. So that's why we're just getting the positive square root. So I'll plug this into my calculator. So I got P is equal to 55 square root of 2. Now, we are to find Q that maximizes the revenue. So we have P here, therefore we have to solve for Q. So to solve for q, you're just going to plug it into the equation here. So you have 36,300 minus 2 times, our p is this value, 55 square root of 2 squared. And let's plug this into our calculator. I got 2,200, so 24,200. This is the value of Q that maximizes the revenue. So for our next problem, we are to differentiate implicitly the following expression. Now, to do this, we are going to differentiate both sides of the equation here with respect to x. We want to find dy dx. So let's do the left-hand side of the equation first. So this expression, we differentiate that with respect to x. So the derivative of e, this is of the form e to the u. So the derivative of that will just be e, let's write that here, d dx of e to the x to the fourth y. The derivative of here is e to the u, so e to the x to the fourth y times the derivative of u with respect to x. So times the derivative of this with respect to x. Now, if you are going to differentiate this, notice that you have two variables. You have x and a y. So to do that, you are going to treat this as, you are going to use this as product rule. Treat both of them as different functions. So you will have to apply product rule here. So you do x to the fourth, you copy one factor first, and then you differentiate y with respect to x. So the derivative of y with respect to x is dy dx. Then you copy y, so you copy the other factor, the one you just differentiated, which is y, and then you differentiate x to the fourth, and the derivative of that will be 4x cubed. So this is the derivative of the left-hand side of the equation. Now, for the right-hand side of the equation, the derivative with respect to x of 5x plus 4y plus 5 is equal to, so you just differentiate each term. So the derivative of 5x is just 5, because you're differentiating it with respect to x. The derivative of x with respect to x is 1. Then for 4y, you have 4 times the derivative of y with respect to x, and that is dy dx. Then you differentiate 5 with respect to x, and that is 0. Okay, so now this is your equation. So to find dy dx, you're going to equate those two. So you will have e to the x to the fourth y times x to the fourth dy dx plus 4yx cubed is equal to 5 plus 4 dy dx. Now we are going to isolate dy dx. How do you do that? You're going to group all those with dy dx. So to do that, you are to distribute each, you're going to distribute e to the 4, x to the fourth y on each term inside the parentheses. So this expression becomes x to the fourth e to the x to the fourth y dy dx, that's the first term. And then the second term is 4yx cubed e to the x to the fourth y is equal to 5 plus 4 dy dx. Next, you group or you put the expression that contains dy dx on one side of the equation. So you have x to the fourth e to the x to the fourth y dy dx minus, so you put this on this side, minus 4 dy dx. Then you retain 5 here. Then you subtract this term here, which is 4yx cubed e to the x to the fourth y. Then you can factor out that dy dx. So you have x to the fourth e to the x to the fourth y minus 4 times dy dx is equal to 5 minus 4y x cubed e to the x to the fourth y. Then finally, you can solve for dy dx by dividing both sides of the expression by the coefficient of dy dx, meaning this expression here. So therefore, this is equal to 5 minus 4y x cubed e to the x to the fourth y all over x to the fourth e to the x to the fourth y minus 4. Next item, find dy dx by implicit differentiation for the following equation. So to do this, we are to differentiate both sides of the equation with respect to the variable here. In this case, with respect to x. So we're going to compute for the derivative with respect to x of 4x plus ln y is equal to the derivative with respect to x of x cubed y to the fourth. Then you distribute, so this side here to differentiate that, you just have to differentiate each term. So you have 4 and the derivative of x with respect to x is just 1 plus then the derivative of ln y. So ln y will be 1. The derivative of ln u is 1 over u, so 1 over y, times the derivative of u, in this case y, with respect to x. So dy dx. This is equal to, now the right-hand side, these two are being multiplied to each other. So that means you are going to use the product rule. So you copy one factor first, and then you differentiate y to the fourth. The derivative of y to the fourth with respect to x is 4y cubed times the derivative of y with respect to x. Plus, now you copy y to the fourth, times the derivative of x cubed, and that is 3x squared, times the derivative of x with respect to x, and that is just equal to 1. Next is to group all those expressions with dy dx. So you have, in this case here, you retain this. You have 1 over y dy dx. Now this expression here will be moved to that side. So that will be a minus. So to remove this, you put a minus. So you have minus, you multiply these two, 4x cubed y cubed dy dx is equal to, you copy that, 3x squared y to the fourth minus 4. This expression here will be moved to this side. So minus 4. Next step is to factor out dy dx. So you have 1 over y minus 4x cubed y cubed times dy dx is equal to 3x squared y to the fourth minus 4. So therefore dy dx is equal to 3x squared y to the fourth minus 4 all over 1 over y minus 4x cubed y cubed. Now, you will then have to, you can simplify this, you can combine the denominator as a single expression, and this is equal to 3x squared y to the fourth minus 4 all over 1 minus 4x to the fourth, x cubed. Now you multiply this here, y to the fourth all over y. Then you flip, you get the reciprocal of the denominator and proceed to multiplication. So you have 3, I'll write that here. This is equal to 3x squared y to the fourth minus 4 all over 1 minus 4x cubed y to the fourth. And then you multiply the numerator here by y. So therefore, this is equal to 3x squared y to the fifth minus 4y all over 1 minus 4x cubed y to the fourth. So next problem, find the equation of the tangent line at the given value of x on the curve. So the curve is an implicit function, and we are to find the equation of the tangent line, and the x value here is given. So to proceed, we would have to first find the slope of the tangent line. To do that, we are to find the derivative of y with respect to x from the equation here, and then evaluate that to find the slope. Okay, so let's see how you would do this. So first, we differentiate both sides of the equation here with respect to x. So we have dx of y cubed plus xy squared minus 25 is equal to dx of x plus 2y squared. Now, all those with variable y, when you differentiate it, will have a dy dx in the end. So therefore, derivative of y cubed is 3y squared dy dx. And then here, you would apply product rule. So you have x times the derivative of y squared, that is 2y dy dx, plus y squared, copy y squared times differentiate x, so that's 1. I'll just write 1 so that you know that the derivative of x here is 1. Minus this, the derivative here with respect to x is just 0. Okay, so on this side, the derivative of x with respect to x is 1, plus the derivative of y squared, or 2y squared, will be 4y, and then you multiply dy dx. Now, to find the derivative, to find the slope, we will have to know what the value of dy dx is, but we will not be able to obtain that without knowing what the y value is, right? Because you have a y here. You only know what x is. So to obtain the value of y, we will have to plug in x equals 2 to the original equation and then solve for y. So you would do y cubed plus 2y squared minus 25 is equal to x is 2. So replace x by 2. So 2 plus 2y squared. And then you would solve for y. So now here, we have a 2y squared here and a 2y squared here. You can subtract both sides by 2y squared, so this 2 cancels. And so therefore, you have y cubed minus 25 is equal to 2. So you have y cubed is equal to, you add 25 on both sides, is equal to 27. So y therefore is equal to 3. So when x is equal to 2, y is equal to 3. Then you can come back here, we can solve for dy dx. So no need to isolate dy dx because we want the value for that. All we need to do now is to just evaluate this expression by x equals 2 and y equals 3. So you have 3, and then replace y by 3 squared, dy dx plus 2 for x, times 2, and then y is 3, dy dx plus y is 3, so 3 squared is equal to 1 plus 4 times 3 dy dx. And then you simplify. So this is 27. It's 27 dy dx plus 4 times 3 is 12 dy dx plus 9 is equal to 1 plus 12 dy dx. These 2 cancels. That cancels. So therefore, if you subtract both sides by 12 dy dx, those 2 will cancel. Then you can move this to the other side of the equation. You subtract 9 on both sides. So you will have 27 dy dx is equal to 1 minus 9, and that is negative 8. Then now you just divide both sides by 27. So dy dx is equal to negative 8 over 27. That is the slope of the line. Now that we have a slope, we can now proceed and use the equation of the line y to find the line. You can use this equation, y minus y sub 1 is equal to m times x minus x sub 1. Now again, our y here is 3. Our x was 2. So we will plug in those values here. So y minus 3, that's your value of y, and the slope will be negative 8 over 27 times x minus, your x was 2. Then you simplify, okay? So you will have y is equal to, let's distribute that to each term. So you have negative 8 over 27x, or 8x over 27. This times this, so that's positive 16 over 27. Then the positive 3 will be added here, so plus 3. And then just combine this 2. All right, so this is just equal to negative 8x over 27 plus, you combine this in your calculator, that gives you 97 over 27. That is the equation of the line. So y, let's just write y here. So y is equal to negative 8x over 27 plus 97 over 27. Next number. Assume x and y are functions of t. Evaluate dy dt for the following expression. So we are given here an implicit expression, and we are to find dy dt, given that dx dt is -4, x is 2, and y is equal to 6. So now to do that, we are just going to differentiate both sides of our equation with respect to t. So this is on related rates. We are going to find the derivative with respect to t on both sides of the equation. So you have y squared minus 3x squared. We're going to differentiate that with respect to t. And then negative, so d dt of -71. Now, you differentiate y squared. That is equal to 2y times dy dt. And then differentiate 3x squared with respect to t. You have -6x, so -3 times 2, that's 6x, dx dt is equal to 0. Now, you plug in all the given here. So for dx dt, that is replaced by -4. X is equal to 2 and y equal to 6. So you have 2 times 6 dy dt minus 6 times 2, and then the dx dt is -4, equal to 0. So this is 12 dy dt, that is positive. So this is now 8 times 6, that's 48. So positive 48 is equal to 0. We will transpose this to that side. You will have 12 dy dx is equal to -48. And so dy dx, you just divide both sides by 12. So therefore, dy dx is just equal to -48 over 12, and that is equal to -4. Now consider the following problem. A company knows that unit cost C and unit revenue R from the production and sale of X units are related by this function. We want to find the rate of change of revenue per unit when the cost per unit is changing by $15 and the revenue is $4,000. Now notice that each of these cost and revenue are changing with respect to the unit. So that means that this one is a related rate problem. So to solve this, we are going to get the derivative of both sides of the equation here with respect to x. All right, so we start by differentiating C with respect to x. So the derivative of C with respect to x is just dc dx is equal to the derivative here, d dx of r squared over 258,000 plus 4127. The derivative of these is equal to, you can factor out 1 over 258,000, and then just differentiate r. The derivative of r is 2r dr dx. So your r here is the revenue. Now the derivative of 4,127 with respect to x is just 0. That is just a constant. Now, so we have dc dx here. Now let's see what's given. It says here that we want to find the rate of change of revenue per unit. So that is dr dx. So that's the unknown. dr dx is what we're looking for. When the cost per unit, so cost per unit, that is dc dx. Cost per unit is changing dc dx by 15. So that means the derivative of c with respect to x is $15 per unit. And the revenue, so R is equal to 4,000. Okay, so we would have to plug in those information to our equation. So we have 15 is equal to, now you can simplify that. This is equal to R. Oh, R, we have a value for R. So you simplify that, that's 1 over 129,000. Oh, no, 12,009. Oh, this one is 1,000. Yeah, so 129,000. And then R is equal to 4,000. We are computing for dr dx. So that cancels. And then we simplify this. We have 15 is equal to 4 over 129 dr dx. We will multiply both sides by 129 over 4. This is 129 over 4. Cancel. Then that is your dr dx. So dr dx is equal to 129 times 15. That's 129, 15, 1935 over 4. Simplify this, divided by 4. That is equal to 483.75. Letter B.